Today, we will be exploring the intriguing question of why, despite the vastness of the universe and the likelihood of other civilizations existing, we have yet to make contact with any of them. This paradox, known as the Fermi Paradox, has puzzled astronomers and scientists for decades. But fear not, as in this video, we will be delving into some of the most popular and credible solutions to this enigma. So sit back, grab a cup of tea, and let's embark on a journey to unravel the mystery of the Fermi Paradox. The Fermi Paradox is a contradiction between the high probability of the existence of extraterrestrial civilizations and the lack of evidence for or contact with such civilizations. It is named after the physicist Enrico Fermi, who first posed the question, where is everybody? Sir Arthur C. Clarke, the late British science fiction author, best described this paradox as the following. Two possibilities exist. Either we are alone in the universe or we are not. Both are equally frightening. This paradox highlights the apparent discrepancy between the apparent likelihood of extraterrestrial civilizations existing and the lack of evidence for or contact with such civilizations. Despite numerous searches for extraterrestrial signals and ongoing efforts to find and study exoplanets, the existence of extraterrestrial civilizations remains one of the great unsolved mysteries of science. The first solution we're going to explore is the Great Filter. The Great Filter hypothesis proposes that the development of intelligent life and civilizations is a very rare and unlikely event in the universe. There may be a series of obstacles or filters that must be overcome in order for a civilization to emerge and survive over a long period of time. These filters could include challenges such as the emergence of simple life, the evolution of complex life, the development of technology, and the ability to avoid self-destruction. The idea is that one or more of these filters may be so difficult to overcome that the chances of a civilization emerging and surviving are extremely low. If this is the case, it would explain why we have not yet found evidence of extraterrestrial civilizations, despite the vastness of the universe and the age of the cosmos. There are two possible implications of the Great Filter hypothesis. One, if the filter is ahead of us, it means that the development of a long-lasting civilization is extremely unlikely and that our future may be bleak. Or two, if the filter is behind us, it means that we have already overcome many of the difficult challenges and that our civilization may be one of the few that has ever existed in the universe. Another solution to the Fermi Paradox is the rare earth hypothesis. The rare earth hypothesis is a concept in the field of astrobiology that suggests that the conditions required for the evolution of complex, intelligent life are very rare and unlikely to occur in the universe. According to this hypothesis, the conditions on Earth, such as the right combination of elements, the presence of a large moon, a stable climate, and a relatively benign galactic environment, are unique and contribute to the emergence of complex life forms. The rare Earth hypothesis posits that the requirements for life are much more stringent than previously thought, and that the majority of the universe may be inhospitable to life. This would mean that the existence of life as we know it, and in particular intelligent life, is a rare and unusual occurrence. This hypothesis challenges the idea that life is a common occurrence in the universe and that the conditions required for life to emerge and evolve are relatively easy to achieve. It also has implications for the search for extraterrestrial life and the likelihood of finding other civilizations in the universe. If the rare earth hypothesis is true, it would mean that the search for extraterrestrial life may be much more difficult than previously thought, and that the chance of finding other civilizations may be much smaller. The zoo hypothesis is another solution to the Fermi Paradox. The zoo hypothesis is a concept in the field of astrobiology and the search for extraterrestrial life. It proposes that extraterrestrial civilizations may be observing humanity but are deliberately avoiding contact with us. The hypothesis suggests that these civilizations may be respecting our autonomy and avoiding interference with our development, similar to the way in which humans observe animals in a zoo. The zoo hypothesis was first proposed as a way to explain the lack of evidence of extraterrestrial life, despite the vastness of the universe and the age of the cosmos. According to the hypothesis, extraterrestrial civilizations may have the technology to communicate with us, but they have chosen not to do so. There are several reasons why extraterrestrial civilizations may choose to observe us in this way. They may consider us to be primitive and not yet ready for contact, or they may be concerned about the impact that contact with a more advanced civilization could have on our development. Additionally, they may be observing us for scientific or anthropological reasons, much as humans study other species on Earth. So there you have it, some of the most promising solutions to the Fermi Paradox. But the truth is, we may never know the true answer. However, the mystery of the Fermi Paradox continues to drive research and exploration, and it remains one of the most intriguing questions of our time. Thank you for watching, and don't forget to give this video a like and subscribe to the channel for more interesting and informative videos. And if you have any thoughts or theories about the Fermi Paradox, be sure to leave a comment below. We would love to hear from you.